Okay, so in this video, we will be talking about the addition rule and complement rule of probability. Under the addition rule, the first thing we will mention are mutually exclusive events. It will be events that cannot occur at the same time or events that do not have anything in common. Probability of mutually exclusive events can be calculated by looking at the probability of A or B will be equal to probability of A plus the probability of B. So what we would do is find the probability of A individually, then find the probability of B individually and add them together. So let's look at an example. Suppose a single card is drawn from a standard deck of playing cards. Find the probability of drawing a 5 or a king. So the first thing you want to ask yourself, are these events mutually exclusive? Or in other words, do these events have anything in common? They are mutually exclusive because they do not have any cards that are in common. There's no such thing as a 5 that is a king. You can't have a 5 of king or king of fives. It would be different if the two events were drawing a heart or drawing a king, because they do have something in common, which is a king of hearts. But you do not have a 5 or a king that would be in common. You cannot be a 5 and a king at the same time. So they are mutually exclusive events. So we start off by finding the sample space. The standard 52 card deck has 52 cards in it. So that's the number of our sample space. Your event, let's call event A drawing a 5. There are 4 5s in the deck. So we take that 4, place it over to 52. The probability of getting a 5 will reduce down to 1 over 13. Event B is drawing a king. There are also 4 kings in the deck. So do the 4 over 52, reduce it down to 1 over 13. Now, since they are mutually exclusive, all we have to do now is add both the 113s together. 1 over 13 plus 1 over 13 would be 2 over 13. So there'll be a 2 out of 13 chance of getting a 5 or a king. Okay, so the general addition rule for probabilities, if you want to know the probability of A or B, whether it's mutually exclusive or not, you do the probability of A plus the probability of B minus the probability of what they have in common. So that's probability of A and B. Now keep in mind what we just discussed was mutually exclusive events. Now, if they're mutually exclusive, they do not have anything in common, and so that means this would be 0. So that's why the other relationship was just the probability of A plus the probability of B. But if they have something in common, we have to consider this piece of the rule. So let's look at why in this next example. Suppose a single die is tossed. Find the probability of rolling an even number or a number greater than 2. Once again, ask yourself, are these events mutually exclusive? No, they are not. They do have something in common. They do have a few numbers that are in common. So let's explore that. The number of your sample space, once again, is what you should look for first. And that's going to be 6, because on a single die, you have 6 faces to your die. The numbers 1 through 6. So that's why the number of my sample space is 6. The first event, rolling an even number. 1 through 6, the number of even numbers, 3. That would be 2, 4, and 6. So we have 3 even numbers. So we place that 3 over 6. A number greater than 2, there will be 4 numbers that are greater than 2 on the face of a die. That's 3, 4, 5, 6. So we do 4 over 6. Now, what they have in common, being even and greater than 2, that would be 4 and 6. So the number that fit, that would be that, the number of outcomes that fit that description would be 2. So we do 2 over 6. Now, the reason why we have to subtract that, look at the formula. We have the probability of A plus the probability of B minus the probability of A and B. When you go back and look at the 3 and the 4, notice this 3 counts 4 and 6, but also this 4 counts 4 and 6. So if you were to add 3 and 4 together, you're actually counting 4 and 6 twice. So that's why in this relationship, you have to subtract at least one account of the 4 and 6. So that's why we're subtracting 2 over 6. So finish off the relationship, finish off the problem. 3, 6 plus 4, 6 minus the 2, 6 will give us 5, 6. Now we'll quickly look at the complement of an event. Complement is the opposite of an event. It represents all outcomes in the sample space that are not in the event. If my event is E, then the complement of my event will be E to the C. We have the C superscript up here. That will be the notation for the complement of your event. The way we'll calculate the probability of the complement of your event, if I wanted the probability of the complement of your event, I would do 1 minus the probability of your event. I made a little mistake right here. So that's 1 minus the probability of your event. So if you know the probability of your event, you can find the probability of the complement by subtracting it from 1. Just like if you know the probability of your complement, you can subtract it from 1 to find the probability of your event. And then if you were to add the probability of your event plus the probability of the complement of your event, that should equal to 1. So those are your relationships dealing with the probability of your complement of your event and the probability of your event. So let's see how we can use this. The probability of tossing a sum of 11 on the toss of 2 dice is 1 out of 18. What is the probability of not tossing a sum of 11 on the toss of 2 dice? So if you let the event be the toss of the sum of 11, and the complement would be not to toss 11. They just told us the probability of tossing 11 is 1 over 18. So what I can do is take that 1 over 18, subtract it from 1, and that'll give me the probability of not tossing an 11. So that's what I did here. We have 1 minus 1 over 18. If you remember your fraction rules, 1 is just 1 over 1 as a fraction. Convert that to a fraction with the same denominator as the 1 over 18. So that means I'll have to turn that 1 to 18 over 18. 18 over 18 is still 1. So 18 over 18 minus 1 over 18, that would be 17 over 18. All right, so let's look at one more example. A die is tossed 4 times. What is the probability that a 6 will show on the upward face at least once? So what's the probability you roll 6 at least once? Once again, establish your sample space first. When I look at rolling the die 1 time, I have 6 options. So that's why I put a 6 here. Each time I roll the die, I have 6 options. I have 6 faces on my die. Nothing is being taken away. So each time I roll it, I have 6. So I want to know the number of outcomes that would give me. I would multiply the 6 to itself 4 times. And that gives me 1,296. All right. If I let my event be at least 1 6 and let the complement of my event be no 6s, I will look here and say that my complement, if I don't want any 6s, that means when I go to roll my die, I only have 5 options, 1 through 5. All right, so don't forget, let's go back to this establishing of my event. If my event is at least 1 6, that means that I can get a 6 the first time and not get a 6 any other time, or I can get all 6s, or I can get 2 6s and no 6s. You know, there are many different ways that that can occur. So we want to know what's the probability of getting at least 1 6. The complement of that is the probability of not getting any 6s at all. So when I go to the complement and establish the number of my complement, I don't want to include 6 as an option. So each one of my die would have the number 5 there, 1 through 5. Just like I did in the last one, multiply them together. 5 times itself 4 times would be 625. So the probability of the complement, the probability of getting no 6s, would be 625 over 1,296. So now that I have the probability of the complement, I can use that to find the probability of my event. And I can do 1 minus the probability of the complement. So there's 1 minus 625 over 1296. And this one would be 1296 over 1296. You subtract those, that'll give me 671 over the 1296. And then if you were to divide that out, that would be approximately 518 or 0.518. So depending on how you want that answer, either one of these would be correct. Let me know if you have any questions.